In this collection of videos, we are going to discuss data types and variables with a particular emphasis on the double variable type. Now, before we go running through some content, I'd like to show you with some code in Visual Studio exactly why understanding data types is going to be important for us. So let's open up that basic shell of a program we discussed last time, and let's ask the computer to print some things to the screen for us. Let's ask the computer to print to the screen, within quotation marks, 3 divided by 2, and then give us a new line. Now, before I compile this bit of code, take a minute and think about what you think will be printed to the screen so you can check that with what actually happens when we compile. So we go ahead and compile, and we see that what is written to the console is exactly what is between those quotations, 3/2. So no division was actually performed. The computer did literally what I asked it to do, which was show to the screen 3/2. It has viewed what's between those quotation marks very literally. It has not done any type of computation or processing with those values, just showed us exactly what was in the IDE. In order to remedy this, we can get the computer to do an actual computation by leaving out the quotation marks. And then the computer will actually do a computation for 3 divided by 2. If we then want to see the results of 3 divided by 2 in the console, we have to ask the program to print 3 divided by 2 to the console. So the line of code to make this happen is cout 3 divided by 2, no quotation marks, and end the line. Now I'm going to go ahead and click compile, and we'll be able to see the output from both the first and the second lines in our console window. But something unexpected has happened here. The first line that's showing up in our console is from the line of code on line 7, where we ask the computer to literally print 3/2. What's going on in line 9 is perhaps unexpected. We've asked the computer to actually go ahead and do the division 3 divided by 2, and then show the result of that computation in the console window. However, the computer has just showed us the number 1, and not a value of 1.5 like we might expect. And the reason that this is happening has to do with data types. Now, the reason why we got the number 1 here is something we will discuss a little bit later in the course. But before we get to that, I'd like to show you how to fix this to get an answer of 1.5 printed out to the console. So let's see that. In order to get that value of 1.5 printed out to the console, and we'll discuss exactly why in later videos, we need to add decimal points to our 3 and our 2. In other words, what we need to type is cout 3.0 divided by 2.0. While the numbers 3 and 3.0 are exactly the same to us, they're represented internally in the computer differently. And as we can see, it makes a difference in the output that we see in the screen. So again, 3 different cout statements that look very similar to us as people in the IDE, and 3 very different answers appearing in the console, 3 very different things done by the computer. So let's explore what's going on here, which, as I said, has to do with data types. Inside our computer, the computer needs to store all sorts of different types of things that people might want to use or do or represent, and it needs to store those internally in different ways. So sometimes people work with integers or doubles, which are numbers. Sometimes people deal with things that are called booleans, which are true or false values. Strings we've already seen, which are things that we may wish to store in the computer that are typed in from the keyboard, like words or phrases. And then there's all sorts of other complicated things that we deal with in the world that we might want the computer to represent. And so computers can even represent things called user-defined data types, which are things that we know and care about, we can then teach to the computer. One example we may see in this course is something like a card from a deck of cards. That's a thing that's important to people. A computer is not naturally posed to understand what that is, but we can teach the computer that. So these are all sorts of different things that we have and know about, and we want to teach to the computer and store within the computer's memory. And what a data type is a set of permissible values and operations that can be performed on those values. So going back to that deck of cards example, if we were to teach the computer what a card in a deck of cards is, the set of permissible values we might want to teach the computer is saying we're always looking for something that's a number 2 through 10 or a letter corresponding to ace, jack, queen, king. And then it also has a suit, and there's only 4 suits that are allowed: hearts, diamonds, clubs, and spades. That would be an example of permissible values for a data type. And then we'd want to talk about operations that can be performed on those values, like maybe we want to take the numerical values that appear on a card and add them together. That would be an example of an operation we may wish to perform onto objects of that particular data type. Now, a couple of things that are going on in the background here that might be important to us, or may be important to you if you've already learned other programming languages. C++ is what's called a statically typed programming language. That means in many ways that it's a little bit rigid, more like wood than water. What this means is that when we have an object for a data type, we need to declare to the program what the data type of that object is. We as users need to know its type, and we need to communicate that to the computer. C++ will not do it for us. Some other programming languages will. And once we've declared, I'm dealing with an object of this particular data type, we are not at liberty to change that about that variable. So that's what it means to be a statically typed programming language. C++ is also what is called a strongly typed programming language, meaning that the data type of an object is important when we start looking at those operations in attempting to combine objects together. In C++, objects of drastically different data types absolutely cannot be combined as a consequence of being a strongly typed language. So if we have 2 objects of a data type that are very similar, we will be able to combine them together. If we have 2 totally different objects of a different data type, but they are the same, they can be combined together. But what is not allowed in C++ is taking 2 different objects, one of one data type and one of another, and combining those together. There are some exceptions that we'll learn about later in the course where we can have different data types on an object and we'll still be able to combine them, but they have to be sort of similar. Something we'll see examples of later. Now, I've been using this word object, but another word that I could be using is the word variable to represent an instance or an example of a data type. What a variable is a container or a space in memory for storing a value of a particular data type. And an analogy that I really like for talking about variables is that of storage lockers. So in my mind, when I'm thinking about memory inside a computer, I'm using this analogy of a giant space full of lockers of different sizes and shapes, one like you might see at an amusement park, to give me a good visual of what's going inside the memory of a computer. So here's an example of that. If I'm looking at a variable in C++, it's always going to have 3 things: a name, a data type, and a value. Now let's see how each of those things is represented with the locker analogy. So every variable has a name. A name is analogous to a locker number. How do I know where I'm going to go in order to access the things that I want to store inside the locker? And what's stored inside the locker is analogous to the value associated with a variable. So the name is the locker number, the value is what's inside. The data type of the variable is more analogous to the size of the locker. You might be able to imagine from the examples we've been giving so far that some things are easier to represent within a computer than others. Something like a number is a very natural thing for a computer to represent internally, and so a computer doesn't always need a lot of space to store just a single number like the number 5. Maybe then, if we have the number 5 being stored in memory within a computer, we have a very small locker. On the other end of that spectrum are some things that are not so natural to a computer, maybe that we teach the computer to understand. So maybe we do go through that effort of teaching a computer what it means to be a card in a deck of cards. That's going to be a hard concept to explain to the computer, and in order to store everything, the computer needs to learn about cards because it doesn't represent that internally very well on its own. We might need a bigger locker to hold all of that information inside, just to even talk about what a card is. So within memory on our computer has the ability to store things in small spaces or larger spaces based on what that data type is. And that's why in C++ it's going to be so important for us to tell the computer the type of an object that we're going to be considering so it knows where to go in memory and how big of a locker to assign to that value that we want to store. Now, when we talk about programming and creating variables in a C++ program, we're going to talk about variables being declared, variables being assigned a value, and then perhaps being reassigned different values later on. This process of talking to the computer and saying, go and allocate a spot in memory for me for this particular variable that I'd like to introduce. That's the declaration process, declaring a variable, and that only happens once within a program. Once we've gone and checked out our locker, so to speak, we're at liberty to take what's inside of the locker out and put new or different things inside later on. That's this process of reassigning values to the variable. The name of the locker hasn't changed. The types of things it can hold hasn't changed, but we are able to change in and out what's within that locker. That process can happen indefinitely. This reassignment process, it's like taking something out of the locker and putting something else back in, and that's called reassigning values to a variable.